Hello algebra students, this is Mr. Montes again, and we are back with some more algebra. This week we will be talking about adding and subtracting polynomials, but before we jump into that, I want to apologize if you hear any kind of an echo, maybe some noise in the background. Currently I'm sitting in my garage on top of some weight plates and with my computers on top of a weight bench. This is the only place that's semi-quiet in my house right now, so you might hear a little bit of an echo or some wind or maybe some other voices that are mine. Again, I apologize in advance. This is really the only place that's the quietest, so hopefully it's not too bad when it gets uploaded. Anyways, let's start with the lesson. We are going to be talking about adding and subtracting polynomials. Before we jump into that, we should really discuss what a polynomial is, and there's some pieces as well about polynomials that we also need to discuss before we start actually adding and subtracting. So let's start off with polynomial. A polynomial is an algebraic expression. Let me get my mouse here. Polynomial is an algebraic expression that is the sum of terms that are numbers, variables, or products of numbers and variables with exponents that are non-negative integers. The expression 5x, 100 minus x, 3x plus 4, 2x cubed y minus 3xy, and x squared plus 4x minus 5 are all examples of polynomials. So this is a pretty big mouthful, and what we're going to do is we're going to try and dissect what this is getting at. So it says a polynomial is an algebraic expression that is the sum of terms. So we might not know what terms are. So let's take a look at that. It's not defined here. But terms are going to be numbers. It could be a number attached to a variable, maybe a number attached to multiple variables, and those variables might even have some sort of exponent attached to it that's positive and it's a whole number. So those are going to be what terms are. But let's do some examples of terms, so that we can kind of see what kind of things we're going to encounter. So terms can be just a number, so like a number like -2, -8, maybe like a +10, or if you want to get kind of fancy, pi is a number, right? It's 3.14 ... continues on forever, doesn't repeat. These are examples of what we call constant terms because they're always the same. So the value of -2 is always going to be -2. It doesn't depend on anything. So these are constant. We could also have terms that have some variables in them. Like we could have just the variable x. That could be a term. The variable a term that could look like 5x, or maybe even like a -6xy. In this case, we have again, examples of more terms that are a little bit more complicated because we're including a variable. And just as a little bit of a side note, the number here, this number 5, the number -6, I know you don't see it here, but we can think of there as being a 1 in front. These are all called coefficients. Coefficients. I hope I spelled that right. Coefficients, if you hear that term, it's really just referring to the number in front of the variable of the term. So the coefficient of this term right here would be 1. The coefficient of this term here would be -6. So a little bit more complicated, we could also add in some exponents. The only rule is that the exponent has to be positive, a positive integer. Right, so non-negative integer. So like let's go 6x squared. Okay, again, that's the term. Another one might be something like -7xy squared. That's another term. As long as the collection of numbers and variables is not separated between those pieces, is not separated by a plus or minus, that's going to be considered to be a term. So when we look at each one of these, they're all connected by multiplication. So each one of them is going to be a term. All right. So now that we have a little bit of an idea of what a term is, when we talk about polynomials, we talk about collections. Polynomials, collections of terms. All of these here are considered to be polynomials. We actually call these monomials. Monomials, and we call them monomials because they have one term. So anything that is just one term is going to be considered a monomial. Binomials are going to have two terms, right? And you can probably guess what the next one's going to be. A trinomial is going to be three terms. So when we talk about polynomials, we're talking about the collection of all nomials, I guess you could say. A collection of all of these. Poly here meaning many, so many terms. All right, so in this case, we have some examples that have been given to us already. 5x, that's an example of a monomial. We got 100 minus x. Notice here that we have a number, and then we have a variable separated by a minus. So there's two terms here, 100 and x. So in this case, this would be a binomial. And then we also have 3x plus 4. Again, another binomial. We got a term 3x, a term 4, and then that's separated by a plus. And then I'm going to skip ahead and go down to this example. Oops. X squared plus 4x minus 5. That would be considered a trinomial because there's three terms. I have the term x squared, the term 4x, and the term 5, and each one of those, in between each one of these is separate. There's a plus or a minus. All right, so a polynomial is going to be a collection of terms, and terms can be numbers, variables, or any combination of those things multiplied together. All right, so what are we going to do with these? Well, we are going to jump into how we add and subtract them, right? So I'm going to go ahead and scroll up here, get rid of that, and we're going to talk about adding and subtracting. Polynomials, adding and subtracting. Polynomials. So the way this works is there's a couple of rules. We can only combine things that we call like terms, right? So what are like terms? Examples of like terms, right? So suppose I had, I should write that out, right? Examples of like terms. Examples of like terms. Because we can only combine things that are alike. When we talked about that before, right? So examples of like terms. We have things like 3 and 8. I can combine 3 and 8. I can subtract them. I can add them. Those would be considered like terms because I have a constant and a constant. So I could subtract them or add them with whatever operation there that I would like to do as far as those two. 2x and 5x. Those are examples of like terms. In this case, we have 2x here, so 2 times x, and we have 5 times x. Something to notice here is that the exponent of x is 1, and the exponent of x here is 1. So we're allowed to combine those together via addition or subtraction. We can even get fancier. We could say, how about 3x squared and negative 2x squared. Again, here we have another example of a like, two like terms. We have the x squared variable here, but over here we also have the x squared variable, so those terms would also be alike. And we can get even fancier and add in an extra variable. So like I could have something like 56xy squared plus, and combine that with maybe plus or minus negative 2xy squared. Again, here the thing to notice is that I'm dealing with xy squares, and here I'm dealing with xy squares as well. I'm sorry about that. Again, when we look up here, we were dealing with x squares. We look up here, we're dealing with x's. And here, in this case, we were just dealing with constants. So really, we can only combine things with other things that look like it. All right. So some non-examples. So these are examples, right? Some non-examples are going to be things like maybe me trying to combine 3x squared and 3x cubed. Those look a lot alike, except this has an x squared, whereas this right here has an x cubed, right? So because those two differ, we cannot combine them, right? So let's try another one. How about 5y cubed and 2x cubed? When I take a look at this, this has a y cubed here. However, we have an x cubed here. Again, these are not alike. They may look similar, but they're not going to be what we call like terms. So these cannot be combined. So these right here cannot be combined. Cannot be combined. Whereas all these right here can be combined. And when I say combined, really what I'm talking about is adding and subtracting them, right? Okay, so let's do maybe one or two examples. So let's give some instructions. Let's say add the, let's go add the two polynomials, and let's do example 1, and let's add 7x squared minus 14x plus 25. We're going to add that to 3x squared plus 3x minus 4. We're actually going to go ahead and do this in the very same way that we tend to add numbers. And what I'm going to do is I'm going to go ahead and take this piece right here, this first polynomial, which is a trinomial, as we can tell, 3 pieces, and we're going to add it to this. We're going to stack them on top of each other. So I'm going to rewrite this as 7x squared minus 14x plus 25. And I'm going to write plus. And I'm going to write this next one down below. I'm going to write it as 3x squared plus 3x minus 4. And the advantage to doing this is that we're actually, if we write these polynomials in order of decreasing degree, as in this is the x squared term, and then this is the x to the 1 term, and then this one has no x. It's in order of decreasing degree here. When I stack them up on top of each other, it actually aligns as far as, you know, the x squares being here, my x's being here, and my constants all being there. So when I add them, I just add 7 and 3 to give me 10. So I have 10x squares. Negative 14x, if I add 3 to that, that's going to be negative 11x's. And then 25 plus a negative 4 is going to be plus 21. So the addition of these two polynomials is going to result in that new polynomial right there. And that's how you add them. If we were trying to subtract, suppose this right here was subtraction instead, I would do the same thing, 7x squared minus 14x plus 25, but this time I would write minus 3x squared plus 3x minus 4. Okay, I would actually have to distribute this negative here and then just add straight down. But what I'm going to do is I'm going to do a couple more examples on the following video that's also going to have to do with this. And we'll go from there.